Before we start, let me do a little quick introduction, a bit of introduction about the environment. Um, you have the chat box, and I see that. Sorry, you'll see that you have the chance to write there. Please do, especially if you are going to have any question, if you miss any point in the presentation or anything. Yes, Michelis. I could hear myself in the local computers, so I think there's something local you might have to fix. Yes, maybe take a look at your sound settings. Okay, so you have the chat box, and as you can see, it's going to be helpful for you. Sandra will be monitoring it, so if you can't understand something or you want me to repeat a section or a part, feel free to shout in there in the chat box, and Sandra will take action and will be happy to tell me that I have to either slow down or answer a question or think or maybe focus on another part of the presentation and so on. So don't worry, don't be shy. Please tell us if there's anything we can do for you. All right, next to it on the right, there are the files you can download. We have some CIDR charts, we have addressing plan how-tos, we have all the documents that we will be mentioning in the presentation. So feel free to download them. There's also the slides of the presentation here you can download. Above it, you see there's a list of participants, and I see we are already at a very high level. We have 29 people already in here. Wow. That's a very, very high number, and that's very good. So I'm happy to see so many people in here today. Now I'm going to start sharing my screen in a moment. You will get a suggestion. We'll have lots of slides with network diagrams and other information. And in the meantime, you see Sandra has disappeared, but she'll be sitting here next to me. Don't worry, she's not leaving the room. It's just so that you can see my bigger face today. I'll be sharing my screen, but you'll get a suggestion. You'll get a button to make the central part of the screen bigger and go full screen. And I suggest you try that because some of the parts in the presentation today in the slides have network diagrams, and it will be more interesting for you to see them in full screen. Last thing before we start is you probably have noticed. As soon as we started recording the webinar today. So even if you get a phone call and you miss some parts, but you feel shy and you don't want to write it in the chat box and ask me to repeat it, don't worry, you'll have a chance to watch the recording of the webinar again. So now that we have set everything, we know how the environment is. Let's get it started. Let me start sharing my screen. I'm going to share the slides we have. This is the IPv6 addressing plan webinar. Why is it important to create an addressing plan? It's important because you want to keep your mental health during the implementation. IPv6 is not that complicated, but differently from IPv4, if we go into subnetting, it can become quite complicated. It can become quite complicated. So it can be that, oh, I see that.
Sorry.
1 second. I can see that. Okay, sorry. Good. Sandra testing for the upcoming polls. Don't worry, we'll fix that. When you start subnetting in IPv6, you'll notice that it can become quite heavy to carry out. But we will show you today that if you follow some simple rules, it will be perfectly fine and much easier than IPv4. And also, it will help you in implementing security policies. And altogether, if you start with an addressing plan fresh now, with the knowledge you have about your IPv4 network, what is the difference? The difference is that nowadays, if you're starting fresh with IPv6, you know where your IPv4 network is. You know You know how much it grew in the last few years, and you can already project for its growth. So you can try to avoid making the mistakes you made probably initially when implementing IPv4 in your network, which means that in the end you can make addressing plans that are scalable, more scalable than what you might have in IPv4, also considering you have a much larger address space, and then you can make it so that you have a more efficient route aggregation. So you can be a little bit more gentle with your routers, with your layer 3 switches, and so on. But what are we talking about here? How can we make things easier? Well, we can do that by looking at the 4-bit boundaries. Every time you look at a digit in an IPv6 address, you're talking about 4 bits. And when you look at 4 bits, you have 16 different values you can have because we're talking about hexadecimal. And these are called either the 4-bit boundaries or they can call it the nibbles. Like, the 8-bit boundaries, you call them a byte, and that's what you byte. And then you can have a little part of it that's a nibble. Now, when we look at the scheme here, we have to consider that we have to have 64 bits for the interface ID for the local network. It is not really set in stone, but it is. Oh, why? Why am I trying to confuse you? Well, we'll see in the next slide that the 64-bit boundary is a bit fixed. If you want your users to connect to a network and use stateless auto-configuration and get an address automatically, for the moment, you must have a 64-bit, you must have a /64. But there are talks about changing this. We're not going into this right now, but be aware that things might change in the future. But for the moment, the rule is that you need to have a /64. And whenever we move from the /64 boundary, so the one that's highlighted here, we move one digit, we have 16 different /64s. And when we move one boundary again, one nibble again, we get a /56, which is one of the recommended subnet sizes for assigning address space. Contains 256 /64s and so on. Whenever we move, we amplify, we add 16 times the number of /64s. Now, with this in mind, what we do? We need to have a /64 for every device because of stateless auto configuration. And many other RFCs followed this rule. It's more than 30. There are some exceptions. Here we wrote that the only exception is a /127 for point-to-point links, although there are discussions about also considering a /126 or 120 and other subnet sizes. So consider that there can be exceptions, but by default, if you want customers, users to connect with their own phones, laptops, or any other device, any other IoT device, think about it, you want to have a /64. With static addressing, things can change and you can do whatever you want. But if you want users to connect by themselves, it needs to be a /64. So what do we have to contain? What do we have to put in an addressing plan? We have to put every part of the address space that we are intending to use then, of course. But what is that? So address space for your internal use, loopback interfaces, all the point-to-point connections, and we have to keep in mind also all the rest of the infrastructure like servers, routers, and other parts of it for your point of presence. Why do we include all of this? There needs to be a little bit of mentality shift from IPv4, whereas in IPv6 you have a larger part of the address space, you have more. And what you can do here is not go ahead and count the single IP address, but look at subnetting and look at making an addressing plan that has a long-term that's like a long-term plan. So considering all the necessities, all the needs you can have in the next 10, 15, 20 years, because you can. Because differently from IPv4, you have the chance, you have enough address space to do so, so go ahead and do it. Now, the recommendation is to start with a /48 per pop, and then separately consider the address space for your customers. So keep it in a separate pool. Now, the loopback interfaces, 1/128 per device, and you might want to consider the fact that with 1/68, you have enough addresses for all your loopbacks in the rest of your network. So when we say take an easy to remember block for loopback addresses, the suggestion can be, and this is a personal suggestion, can be to take the very first /64, because then you can fill it up with zeros, the very first /64 in your allocation, fill it up with zeros, and then use the second part of the address, the second 64 bits, for defining where that device is. And we'll give you some hints in a moment, in the second part of this webinar. For the point-to-point links, there needs to be a longer discussion than just one slide. What is the point here? There have been, in different times, different times in the history, different RFCs pointing to different solutions for numbering point-to-point links. We've counted up to 5, and each one of them had its own reasons for stating using either a /64 or a /127, or even better, a /126, and so on. Now, the last one, published RFC, is the one we're mentioning here, RFC 6164, which suggests to use a /127 per point-to-point connection. When we say with new router operating software, we mean something that's at least 2-3 years old. That would still cover the case here. One thing that's worth mentioning is that there is a draft RFC. There's a draft being discussed right now, which is about the different options you have for point-to-point links. It's from Jordi Palet, and he shows in that draft the different solutions you can have and the different cases when to use a /127 or when to use different other numbering schemes. Now, the suggestion we can give you is to take a /127 for the exact point-to-point link, but reserve the whole /64 for the whole point, for the whole link. So for every link, get a different /64, because we don't know, we can't know right now what the situation will be in a few years, if there's going to be another a different idea, different methodology for numbering point-to-point links. So try to be conservative. You have enough address space, again, for keeping a /64 for every point-to-point link. And then out of that /64, you use 2 addresses. Now, how can we put this all in practice? We have a scheme here that we give you. And if you've ever been to one of our training courses, you will notice that it looks very familiar, because it's exactly the exercise we have there. But let's look at it. Let's look at it in a different perspective. We have 2 different pops, and for every one of these pops, we will assign a /48. We have 1/32, and we will work on these 4-bit boundaries. So for easy reference, we put here the number of /64s in the different subnets we have here. So we have for a /56, remember, 256, and for a /52, we have 4,000 /64s available. Now, the suggestion is, look at the number of point-to-point links you have for a device, or for a router, for a switch, And just to be sure, as I mentioned in the previous slide, reserve a /64 per link. So let's have a poll now. Looking at the network scheme here, we have CR1 POP2, which is the router in the middle in POP2. Let me see if I can circle around it. There you go. Around this. I can't see my own pointer on my screen, so I'll have to rely on another screen. But that one, no, it's okay. Voila. How much would you assign to CR1.pop2? Consider the number, say, of interfaces, the number of links, and consider for every one of these a /64. Let me see if I can see something. Okay, I'll give you a moment to answer. Is the poll open?
Yeah.
Yes.
CC?
Okay, I see answers coming in. And I'll take a sip of water. Please, I see we have a large number of participants. Go ahead and tell me. I see answers coming in. We have 3 so far, but I know we have 30 people in the webinar. Okay, I see 6 now. Good. I see now 7 answers. Please, 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 let's have a bit of a discussion about it. It is anonymous. We can't see who answered. So don't worry. I see 9 answers so far, and that's really good. 11. Yes, I'll wait another few seconds for your answers coming in. We have 12. Yes. Okay. So 5, 4, 3, 2, 1. Okay, let's see the results. So now Sandra is broadcasting them. Okay, good. I see that. We have a broad range of answers, and we go from /64, I have 48s, I have 56s, and I also have someone who said 10 or 16. Okay, we'll work on that in a moment. Now, let's take a step back and think. We have a router. CR1.pop2 is a router in the in our POP. A router can have a series of interfaces, a series of links. So here we can have 2 different. We can look at it from 2 different perspectives. If we look at the physical interfaces, we have a router can say have 200 interfaces. There are really routers with different line cards, and they can have up say 256 interfaces. Now think about it and think about the numbers that we saw in the previous slide. So in this case, one of the ways we can look at it is let's reserve a /64 for every physical interface this router can have. And then one of the suggestions is to go for a /56. In a /56, we can take 256 /64s. So that is one way of looking at it. And I see many of you have chosen that. Looking at it in a slightly different perspective, a router can handle VLANs as well. And let me see, how many VLANs, can you write it in the chat? How many VLANs do routers support generally? If we don't look at Q&Q or other technologies by default. Okay, yes, I see Lawrence, sorry if I mispronounced your name, 4096, there you go. Where did we see that number? Where did we see 4096 recently? In one of the previous slides. Can you write it in the chat? Can you also think about where we saw that? No ideas? I don't see anyone typing. Yes. Okay, good. FS, it's a /52. Great. In a /52, we have 4096 /64s. So if we take a slightly different approach. We can think about, okay, let's reserve for this router a /52. What is the difference between the two? Oh, by the way, I see that no one suggested a /52. Then I'll go into the other suggestions we have in the answers here in a moment. What's the difference between considering 1/52 and 1/56? If I choose a /52, I have one limitation, because in the POP I have, so far, I have only 1/48. So if I choose to assign 1/52 to every device in there, how many networks, how many devices could I number out of this? I go from 1/48 to, okay, great, I see 16, perfect. So I'm limiting myself, which could be a limitation depending on the size of the POP, to 16 devices. And then I will have to assign another /48 to my POP. Exactly. Whereas if I use a /56, how many devices could I number out of that? Let's see. Guess 99. You were perfect with the first calculation. Can you attempt to see how many /56s we would have in a /48? Let's see. 256. Perfect. Yes, exactly. Very good. Very good. Thanks. Yes, so you would have space for 256 devices. This depends on your approach. It depends on how big your POP can be. And it depends on what kind of numbering you want to use. There's no right or wrong. It just depends on the approach you're going to take. Yes. So this is good. So far, I gave you I spoon-fed you with what the two best solutions could be. Now let's look at your answers. If I give a /64 only, I see a few of you answered /64 in the poll. If I use one single /64, I'll find myself in a little bit of trouble. It would work. I could still use it because for a point-to-point link, I would have to take a /127, two addresses, and I have plenty of them in my /64. That's true. But for many people, this is considered being too conservative. I think this is about the fact that you have to think different with IPv6 from IPv4. Don't be too strict. Leave space for growth and make it so that in the future you'll be able to expand. So using one single /64 could perfectly work, but if you look at the future, it might not be as future-proof as using a /56 or a /52. Now, the other options I see here are to use a /60. That would also work. If I use a /60, I'm, let's say, limiting myself in growth to 16 physical interfaces or 16 VLANs. For a small POP, that could work. That could perfectly work. But why limiting ourselves when we have plenty of /56s and /52s in our network, in our allocation? Consider that if we take 1/32, that's the smallest allocation possible from the RIPE NCC, you would have space for 16 million /56s, which is a lot. You would have 2 million /52s. And if we consider the fact that you can enlarge your allocation, you can get up to a /29, no questions asked, which means 8 times as many. You will end up with 128 million /56s. So why be conservative when we have all this address space available and we can make use of it? And remember, I'm not suggesting to waste address space, I'm suggesting to make use of it. So think about this. Now, let's yes, I probably can't understand why you answered 16 or 10 in there, but we'll check that later on, maybe. So Next, guidelines for ISPs. 1/48 per pop, as we did in the example here. Make sure you calculate for growth. You have all your knowledge about your network with IPv4. You can probably look back a few years and see how much the network grew in this period, and then account for the growth in the next 10, 15, 20 years. You can. You have enough address space to do it. While calculating for growth, you can make it so that your addressing plan will be also scalable, because consider sparse assignment and sparse allocation so that in the future, when you have to enlarge a POP, to enlarge a part of your network, you don't have to renumber, you don't have to add a separate, say, /48, but you can take the contiguous /48, the contiguous /47, and so on, and just aggregate everything as much as possible so that you make everything scalable. Now, what about the customers? What about the other side? Customers should get a large block of addresses. And this is because of all the applications that we see are starting to get there with IPv6. Consider all the Internet of Things. Consider the new standards like HomeNet, which I suggest you take a look at. So the suggestion is for residential customers to go between a /48 or a /56. For business customers, just big rule of thumb, one size fits all, a /48. That means that they will get a large chunk of addresses, and we'll see in a moment how this can be used to your advantage, to their advantage as well. Why do we stop at the /48? Well, because that's big enough, but also because the community, the RIPE community, decided that a /48 was the viable size for everyone, and the largest one you can assign by yourself as a local internet registry, as an LAR. Bigger than that, you need to send a request form to the RIPE NCC to evaluate the assignment that you're making. So if you have a customer who wants more than a /48, you have to follow a certain procedure, ask the RIPE NCC for an opinion, and make sure you're doing things right for this customer. Also important, we mention it here, is that every assignment, so every network, be it a /64 or a /48, needs to be registered in the RIPE database. There are different ways of doing so, and I suggest, if you're interested in this, to take a look at the basic IPv6, the Introduction to IPv6 webinar, also the basic IPv6 training course, and most of it, also the, on top of everything, the RIPE NCC Academy, because there we have a training course that also shows you how to create all these objects in the database and how to do it properly. Now, for customers, the example situation. Now, we are going to look at a big example of how your customers could be guided in assigning these addresses to their own infrastructure. So imagine we have a customer and we gave them a /48, and this customer has different networks, one for the servers, one for the office PCs, one for some network engineers. They do have some local network engineers, and they have their own PCs, and they want to be separated from the rest of the office. Then we have a guest network, and we want to have a network for VPNs, so for the remote workers or the road warriors, call them however you want. And then a little part for infrastructure, so keep space for some point-to-point links and also for the loopbacks. What does this translate into? We'll see in a moment, but first of all, we have to also think at something different. We need locations. We have, imagine a main building, first floor, we have a second floor in the main building, and then we also have a secondary office. This customer has a /48 that it received. 2001, 0db8, 1A2B /48. Now we're going to work on the 4-bit boundaries. So we have 6 functions, the ones we saw, the network engineers PCs, the office PCs, and so on, which leaves room for 10 more functions. What does this mean? Why do we sum them up to 16? We're working on a 4-bit boundary. As we saw earlier, every 4-bit boundary means 16 different values, because we're talking hexadecimal in IPv6. So when we look at the function, we can take one of these 4-bit boundaries, so namely one of the digits in our addresses, and make it have a specific value for every function we have. So we still have space for 10 more functions. And also, we take another 4-bit boundary, another nibble, another digit, and we make it so that the value in the digit tells us in which location the network is. We have 3 locations so far, so we still have space for 13 more locations. And then we also have 2 4-bit boundaries left, 8 bits. So this gives us enough space for 256 networks for every function, for every location. Let's look at some practical examples. We have function and location, and you see that in the address. We start from a /48. And then we have these 4-bit boundaries, these 16 bits translated into 4 nibbles that give us the final /64. So depending on what function this network has to have, and depending on the location this network will be used in, there will be a different value in there. And also, for every function in every location, we're going to have different networks. So, more practical examples. We have servers. So we have a 1 in the function. Main building first floor is the 0, so it's the second 0 there. And then network 0, the very first network. There we go. So we have the same servers, but in the secondary office, we'll just differ a little bit, and we'll have a 2 instead of a 0 in the /56 boundary. Now, if we want to have guests in the secondary office, network number 9, that's what we have. That's the last example in this slide. Again, we have loopback addresses. So we said 0, and then infrastructure. It's infrastructure, so the location doesn't apply in here. We distribute the loopback addresses inside our whole infrastructure. For a point-to-point link, we have infrastructure again, so it's a 0, and then 102, the location doesn't apply. So this would be the our /127 inside this /64. And then we have addresses for the VPNs in the main office on the first floor, and then we have user 171. And this can be a bit confusing. Why do we have AB while we say the user is 171? Let's see if you paid attention. Can you answer to me in the chat? Why do we have this? Why do we have AB instead of the actual number? It's a very simple question. So this also allows me to have time to drink a little bit of water. No one? No one's answering? You see, I see someone's typing. Yes, AB in hexadecimal is 171. Perfect, thank you. I just want to use these questions to see if you're paying attention and if you see how things are. So the previous example was just an idea. Now you can adapt it as necessary, and depending on the different locations, the different functions, the different buildings you have. Imagine if you have more than 16 buildings in your campus, and this is an option, this can happen, or you have more than 16 floors, or I don't know, different values that need to be more than 16, you can amplify, you can make that part bigger and go and move to 256. So another example is having 256 functions. for 16 locations and 16 networks for every function for every location. So this is really something that makes your addressing plan flexible and helps you in understanding where a network should be used, what its function is, just by looking at it. Now, final tips before we have some questions for you is, again, work on the 4-bit boundary, because that makes things way easier than just doing subnetting based on without any boundaries. But group everything by function, by location, and again, we can't stress this enough. Try to make a scalable addressing plan. IPv6 is relatively new for some. Consider you're starting fresh. Make it so that you can grow as much as you can in the future. Now, we have another poll, and Sandra is starting it in a moment. What is, let's see if you paid attention, the IPv6 address for an engineer's PC in the main building, floor 2, for computer number 2? Sandra is starting the poll. Okay, there it is. Okay, type your answer there. What is the IPv6 address for an engineer's PC, main building, second floor, computer number 2? I'll give you a few seconds to do so. Type the answer in the poll window on the top left, yes, in the screen. Don't see any answers coming in. We have 29 people in the room. Come on. Okay, I see one came in, 2, great. Okay, they're coming. Okay, we have 3 answers. Come on, please. 4 answers. 5. Okay. 6, yes. Come on, 7. I see the number growing. 8. We still have 21 people in the room who haven't answered. Come on, guys. Let us know if we did right, if you understood the concepts here, and see if you can apply them later on in your network. 8 answers so far. Okay, I'll give you a few more seconds. Let me get another sip of water. 10, yes. Okay. Okay. 3, 2, 1. Okay, let's close the poll and broadcast the results. There we go. So let's focus on the little part there on the function. We said that we need an engineer's PC, so that needs to be a 3. So it's 2001 0db8 1A2B column 3, because we need an engineer's PC. Main building, second floor, so that needs to be 1, so 3, 1, and then network computer number 2, so 3, 1, 0, 2. And I see that many of you got it right. 3, 1, 0, 2. It's perfect. Okay. Great. Yes. Now, how can you... Yeah, while Sandra removes the poll, we have a suggestion for you. If you want to learn more, we have a document for you. You can actually also download it in the file section in the webinar here. This is a document that was written by Surfnet in Dutch, and then it was translated by a colleague and made it as a nice document for you. It gives you a deeper understanding of how you can do such an addressing plan with functions and location. Oh, I see this. Okay. Well, Sandra will work on it. I see that you're pointing that the page doesn't exist, but you have the link in the files section. It's the IPv6 addressing plan how to, the PDF. So you can get the document there, and in the meantime, Sandra is checking the link. But this document can be helpful for both you and your customers sorry, to understand how better to perform an addressing plan and write it for a /48 for your customers or your internal use. Now, we have another exercise where we're going to use the chat window to choose the assignments for the www VLAN, the Colo one, so consider that there are 250 customers behind it, CR1 POP2 and CR1 POP1, and the point-to-point customer one. So let's go step by step. Let me turn these. Okay. Okay, I see we have a question. I'll get back to that in a moment, Milos, because we can do it when we wrap up the webinar. Let's try to do this exercise, and then we'll go back to this in a moment. Okay. Okay, let's go one step at a time. For the www VLAN, for the web VLAN, what would you assign in terms of address space? How big? Can you write it in the chat window? How big of address space would you give to the web VLAN? It's on the left in POP1. It doesn't have to be that big. See, some people are typing. Yes, it can be a /64 in this case, but also you could do a /56. That would also make sense. Because imagine if you give a /52 to the local switches, then you can do a /56 to every separate service in there. That's good. Also /64 would do perfect. Now, Colo 1. Colo 1 has 250 customers. So in this case, we're not considering the address space for the customers, but because that will be taken from a different part. But Colo 1 needs to have all the point-to-point links for the different customers. Customers will need to have a way to talk to it. So how big of an address space for Colo 1? Yes, for Colo 1 would we use? Yes, a /56 would do. A /52 would be also good and would allow for a larger set of customers, maybe for growth. Yes, perfect. Yes, both 56 and 52 are very good suggestions in this case. Good. Now, we've done already the exercise with CR1 POP2 and CR1 POP1. What would be the options for these two? Let's see these. How big of an address space would you do for the two of them? A /56, that would be perfect. Exactly. If you look at the physical interfaces, what would the other option be? That would be a slash. I don't see anyone typing. It would be a slash. Yes. Come on. I see someone. Let's see. Let's say a /52 in this case. We could do 56 or 52, and we've already discussed it in the previous section. The point-to-point to customer 1. There, what would you do? How much address space would you do to would you give to the point-to-point to customer 1? There, perfect. A /64 would be more than enough. Yes. And then let me add something here. For a point-to-point link for the customers, you can also use just link local addresses, and you can leave the rest basically unnumbered. It can be easier to do it because you don't have to assign a /64. You will just use, I'll get to that in a moment, Milos. You just use the link local addresses on the public interfaces. You can do that. It will be in the way when you're troubleshooting issues on the network, because the trace route will just show nice stars for that point-to-point link, but that's okay. You can work around it. But also, the suggestion from Milos is perfect. We're picking a /64 but then on the router, we will configure a /127 because that's the recommendation we have right now in the RFCs for what to do for point-to-point link. Yes. We do have a solution, and you can actually download the PDF with the solutions to this whole addressing plan, and I suggest you do so in the files section. So there's solution 1, which involves using /56s everywhere, and solution 2, which uses /52s everywhere. And then we do also the web server VLAN for a /64, but also that could be done with a /56 in this case, because you do have enough space for doing so. So I see there is a question. Now let me go back to answer Milos. So the ISP networks for customers. So if a network has 17 VLANs, okay. In this case, if you're talking about regions, I would move the regions a bit further up the chain and consider using so you have 17 regions. That's unfortunate because you're just one above the 16 limit. But then you can take two 4-bit boundaries, two nibbles between the /32 and /48, and use that to identify the different regions in your configuration. And in each VLAN, 100 and 200 customers. So in that case, you can take a different /48 per region, and then in each region you would fit 256 customers. Because yes, you can go from 32 to 30 to 40. You take a /40 per region. You can take a /48 per. Yes, sorry, I'm mumbling numbers, but because I'm doing lots of calculations in my head. But you could take two 4-bit boundaries to define the region, and that can be done between the 32-bit boundary and the 48. Take maybe one /48 per region, and then use it to fill in your customers in there. So that could also be done. Do we have any other question? I don't think so, unless you will have something to type. You're welcome, Milos. While you type your questions, if you have any, let me tell you about the Academy, which I already mentioned. What can you find in the RIPE NCC Academy? You can find 3 training courses for the moment. 3 courses you can do online for free, and which give you a certificate of knowledge once you finish them. The 3 courses are one about basic IPv6, one about being an LAR, so all the basic knowledge you need when you become a member, and then last, RIPE database training course. So you find these 3 courses, each one of them you can do it online for free in the Academy, and you can get a certificate of knowledge for it. We also do have a Twitter account. And let me say, before we close, on Wednesday, we will also have a big event called the RIPE NCC Educa. Now, Sandra will paste the address, like the link to find out more about this event, because on Wednesday, it's the 6th of June, and it's 6 years after World IPv6 Launch Day. So we are organizing a whole day full of presentations about IPv6. If you're interested in IPv6, yes, it's all online. Yes, Sandra was reminding me. It's all online for free. You can register. Sandra is sending you the link now with the agenda we have at the moment. I'm going to update it in a moment as soon as we finish the webinar to add more information about the specific talks, but we have a great lineup of presenters, of people participating there. We are going to be using the same exact tool that we use today, so you already will be knowing how it works. You can register for free. It's all about IPv6, and there's a lot to learn on that day and to see how people have implemented IPv6 in their own networks. So if you want to learn about it, please go there and register for the Sorry. Oh, yes, yes. Well, the environment will be the same, but the link will be different. Sandra was reminding me because we're going to use a different room for that because we need a much bigger space. Now, with this, we have finished. You can still send us any questions. I'm going to write my email address and Sandra's. And feel free to send us any questions you have about this. And with this, thank you very much. I hope you enjoyed it. I see we had lots of people. We had 29 participants. But thank you very much for being here. I hope you learned at least something today, and I hope it will be useful for you in your IPv6 implementations. And bye.